you brush red dust off something impossibly intact. A curved yellow-brown shape sits perfectly preserved on a rocky pedestal, its skin unwrinkled after ages of exposure. Beside it lies a mountain of rust, all that remains of a rover once considered indestructible. A banana peel tossed on the Martian surface today could still look exactly the same a million years from now, long after every steel rover humanity ever sent there has crumbled into dust. Nothing about this scene follows Earth's usual rules of decay. Somehow the fragile piece of fruit outlived the machine built to survive Mars. Decomposition on Earth requires 3 specific ingredients working together in perfect harmony. Bacteria break down organic tissue, consuming it cell by cell. Oxygen fuels that bacterial activity, feeding microscopic organisms doing the actual work. Moisture keeps everything soft enough for those microbes to digest properly. Remove any single ingredient, and rotting slows dramatically or stops entirely. Mars removes all 3 ingredients simultaneously, leaving nothing for decomposition to grab onto. The Martian atmosphere consists almost entirely of carbon dioxide, holding barely a trace of oxygen. Water molecules exposed to that thin atmosphere sublimate away almost instantly under near vacuum pressure. That cold locks moisture into ice rather than allowing liquid water to exist. Organic waste exposed to this environment undergoes a strange, accelerated freeze-drying process instead of rotting. Scientists use that exact same method to preserve astronaut food for long missions. Mars performs this process automatically, instantly, and with total permanence built into every layer. A banana peel entering this cycle stops mid-transformation, locked forever in whatever shape it held the moment it landed. Nothing continues eating away at its structure afterward, since nothing capable of eating survives the environment long. Humans instinctively assume anything organic left outside will eventually rot away and vanish completely. That assumption comes from a lifetime spent watching apple cores and food scraps decompose in backyard bins. Every rotting banana, every moldy piece of bread reinforce this deeply ingrained expectation. Mars shatters that expectation the moment organic material touches its surface. Scientists have already confirmed ancient organic molecules surviving intact for roughly 3.5 billion years on Mars. Cold, dry, oxygen-starved conditions preserved those molecules across a span longer than most fossils on Earth. A banana peel dropped into that same environment would face an identical fate. Treating Martian trash as biodegradable repeats an assumption that simply doesn't apply here. That single mistake could turn a colony's landfill into an accidental permanent monument, standing long before every human who created it has been forgotten. Picture the mechanism unfolding at the molecular level inside that discarded peel. Cell walls inside the banana's tissue depend entirely on liquid water to stay soft and pliable. Mars offers no liquid water anywhere near the surface, only ice and vapor. Water content inside the peel sublimates directly from solid ice into vapor, skipping the liquid stage entirely. Tissue locks into place instantly, frozen in a state resembling the moment it was discarded. Oxygen-breathing bacteria that would normally consume that tissue simply cannot function in this environment. Cosmic and solar radiation strikes the Martian surface without any thick atmosphere to block it. That radiation sterilizes surviving Earth bacteria clinging to the peel's surface within a relatively short window. Even microscopic decomposers lose their chance to finish the job before radiation eliminates them entirely. The steel rover nearby faces an entirely different, far crueler fate across those same million years. Perchlorate-rich Martian soil reacts constantly with exposed metal surfaces, driving relentless oxidation forward. Thermal cycling between blistering daytime heat and brutal nighttime cold stresses every joint and seam. Metal alloys expand and contract repeatedly, weakening gradually with each temperature swing across the Martian day. Rover parts designed for a mission lasting mere years crumble across geological timescales instead. Wheels warp, circuits fracture, and solar panels shatter under decades of unfiltered radiation exposure. Paint flakes away first, exposing bare metal directly to the elements underneath. Rust spreads slowly across every surface, converting solid steel into brittle, crumbling orange dust. Engineers who designed this rover assumed a mission lifespan measured in years, never in eons. NASA has already grappled with this exact paradox on a mission-critical scale long before any rover ever launched. Planetary protection protocols limit spacecraft to as few as 300 microbial spores total before launch. Engineers scrub every surface meticulously, understanding just how difficult sterilization becomes once spacecraft reach Mars. Scientists built these strict rules specifically because biological material can persist far longer than anyone initially assumed. Every rover component undergoes rigorous cleaning, precisely to prevent Earth life from contaminating another world permanently. That level of caution reveals how seriously scientists treat Mars's unique preservation power. Nothing sent to Mars simply disappears once it arrives, regardless of size or composition. Even a single surviving microbe carries the potential to persist far longer than engineers ever intended. Consider the staggering scale hidden inside that 3.5 billion year preservation window. Organic molecules trapped inside Martian rock have outlasted entire mountain ranges eroding away on Earth. Meanwhile, structures humans consider permanent, cathedrals, monuments, skyscrapers, would barely register as a blink across that same timescale. Mars doesn't measure time the way human civilization does. It measures time in slow planetary silence. A banana peel, dropped almost carelessly, suddenly inherits access to that same silent, patient timescale. Somewhere between those two extremes sits the rover, aging in mere decades what would take Earth centuries to accomplish. Future colonists face a deeply practical epiphany buried inside this bizarre preservation puzzle. Waste management on Mars cannot rely on Earth's comfortable assumption that things simply go away eventually. Every scrap of organic material left exposed risks becoming a permanent fixture on the landscape. Engineers designing Mars habitats now plan around this problem directly rather than trusting nature to handle it. Incineration systems reduce organic waste to ash, bypassing the need for bacteria entirely. Pyrolysis chambers break down material using heat alone, avoiding oxygen-dependent decomposition altogether. Trash-to-gas systems convert waste into usable gas, actively destroying organic material through chemical processing. Every one of these systems exists specifically because Mars refuses to decompose anything on its own. Colonists training for future missions learn this lesson early, often through blunt, memorable examples during orientation. Instructors point directly to the 3.5 billion-year-old organic molecules as proof of what awaits careless waste disposal. Every apple core, coffee filter, or discarded wrapper carries the same preservation risk once exposed to Martian air. Waste bins aboard future habitats route directly into incineration or pyrolysis units rather than simple storage. Nothing gets buried casually the way trash might get buried in an Earth backyard. Engineers treat every organic scrap as a potential long-term artifact requiring active destruction. That mindset shift represents one of the strangest adjustments colonists must make before departure. Some engineers half-joke that Mars turns every landfill into an accidental museum exhibit. A planet stripped of water, oxygen, and a thick atmosphere doesn't erase the traces we leave. It preserves them with a permanence Earth could never offer, turning even our smallest, most disposable habits into potential geological artifacts. That truth reshapes how humanity should think about every object carried toward Mars. Footprints pressed into Martian dust could theoretically outlast the rovers that created similar tracks decades earlier. Flags planted during early missions might fade from radiation exposure while still holding their basic shape for centuries. Every choice made by early colonists carries consequences stretching across timescales far beyond typical human planning. Nothing about Martian permanence forgives carelessness, since even small mistakes become monuments instead of memories. A single discarded wrapper could theoretically outlast entire generations of human civilization back on Earth. The first true monument humanity leaves on another world might not be a flag or a footprint, but the quietly immortal remains of its garbage. That possibility carries a strange mixture of comedy and genuine unease once fully considered. Future archaeologists, whether human or otherwise, might study discarded food wrappers with the same seriousness reserved for ancient artifacts. A banana peel could theoretically become more scientifically significant than the rover that carried it there. Mission planners already factor this reality into long-term colony design, treating waste as a legacy issue rather than a daily chore. Every habitat blueprint now includes dedicated systems specifically built to erase what Mars would otherwise preserve forever. Engineers researching Mars habitats continue refining these waste destruction systems as permanent settlements move closer to reality. Future missions towards the Martian moons, or eventually towards the outer solar system, will likely encounter similar preservation puzzles. Every airless, water-starved world humanity visits offers its own version of this same paradox. Objects considered disposable on Earth could become accidental time capsules on worlds without bacteria, oxygen, or rain. Titan's frozen surface, Europa's icy shell, and the Moon's airless plains each promise their own version of this strange immortality. Somewhere beyond every rover humanity sends to Mars, ordinary trash quietly waits, patient and unchanging, ready to outlast whatever machine humanity trusted to explore that world first.